Okay, so in this, this is more of a kind of tutorial video as such. There's two questions here that I would like you to try on your own. So what I'm going to say in a second is I want you to pause the video and then try this question on your own and then compare with what I do afterwards. Okay, so you can pause it now and off you go. Okay, welcome back, whatever. Right, let's go. So I'm going to go a little bit faster here because this is just to check your own work. All the theory has been covered in previous questions. I'll call this a tutorial lecture as such. So I'm going to go quite quick. So I'm looking at the partial derivative of z with respect to x. I'm going to differentiate this with respect to x. I'm going to fix the constant y. The derivative of x cubed with respect to x is 3x squared plus the derivative of y squared with respect to x is 0. This is equal to 3x squared y. The question is also looking for me to find the second derivative with respect to x, so I need to differentiate this again. Now I'll write more than necessary instead of explanation. So the second derivative with respect to x means take the first derivative with respect to x and differentiate it with respect to x again. The first derivative with respect to x is 3x squared y, and to differentiate this with respect to x I will fix the constant 3y, and then the derivative of x squared with respect to x is 2x, and it'd be nice to simplify this to 6xy. So compare this to what you got. And then I'm looking at the mixed partial derivative. Now technically you should be calculating first with respect to y and then with respect to x. But what might be clever to do is to say, okay, I've already differentiated with respect to y. Let's use the fact that the mixed second order second derivatives are equal to swap this around to first x then y. So this means differentiate with respect to x, then differentiate that with respect to y. And I've already found the first derivative with respect to x. It's 3x squared y. Now you don't have to write all of this, we're just trying to get, I'm only interested in the answers really, although some notation is good. So differentiating this with respect to y, the constant is 3x squared, and the derivative of y with respect to y is 1, so I end up with 3x squared. Okay. If you haven't tried this second example, which is to show that the second derivative log of x squared plus y squared with respect to x plus the other second derivative with respect to y both times equal to 0, pause now and try it. Okay, welcome back. We are differentiating, and again I'm going to go quite quickly here. We are differentiating, we're talking, maybe I'll write the function up the top so everyone can see it here. We're talking about z is log of x squared plus y squared. Right, so we want to find the second derivative with respect to x. We start by doing the first derivative with respect to x. This is log as a function of x squared plus y squared, so it certainly needs the chain rule. The chain rule says differentiate the outside function, log of x. The derivative of log of x is 1 over x. The chain rule says evaluate at the inside. That's x squared plus y squared. The chain rule says multiply by the derivative of what's inside, and I want to differentiate with respect to x. The derivative of x squared with respect to x is 2x, plus the derivative of a constant y squared with respect to x is 0, and I end up with 2x divided by x squared plus y squared. Now, if I'm differentiating this again with respect to x, it's a function of x divided by a function of x. If I want to differentiate this, I need the quotient rule, the formula for which is on page 149, the previous page. So let's see what we get. The second derivative of z with respect to x. Remember, this example is just for you to check your own work. So the quotient rule in the previous page says the derivative of a fraction is the bottom by the derivative of the top. With respect to x, well, what I'm going to do is I'm going to fix my 2, and the derivative of x with respect to x is 1, minus the top, which is 2x, times the derivative of the bottom, x squared plus y squared. The derivative of x squared is 2x. The derivative of y squared with respect to x is 0. Divided by the bottom squared. It's difficult to simplify this, but ultimately you've got 2y squared and you've got 2x squared minus 4x squared. That's minus 2x squared. So again, you're just checking this. You're just checking this against your own work. Okay, so that's the second derivative with respect to x. Now let's look at the second derivative with respect to y. Now it'll be very, very similar work. I'm just going to proceed. The first derivative with respect to y, the chain rule says differentiate the outside. The derivative log is 1 over x. Evaluated the inside is x squared plus y squared times the derivative of what's inside. With respect to y, the derivative of x squared is 0 plus the derivative of y squared is 2y. And this is equal to 2y divided by x squared plus y squared. It's a function of a function of y divided by a function of y. So if I want to differentiate it with respect to y, I need to use the quotient rule. The quotient rule says the derivative is the bottom by the derivative of the top. The derivative, now I want to differentiate 2y with respect to y. I'm going to fix the constant 2, and the derivative of y with respect to y is 1, minus the top by the derivative of the bottom. The derivative of x squared plus y squared with respect to y, the derivative of x squared with respect to y is 0, plus the derivative of y squared with respect to y is 2y. All divided by, this is what the quotient rule says, the bottom squared. So compare this against your own work, and then the simplifying. So I have, what do I see? I see 2x squared, and I see 2y squared minus 4y squared is minus 2y squared. And I will add these two second derivatives together and show that I get 0. So the second derivative with respect to x plus the second derivative with respect to y is equal to, okay, so this is the second derivative with respect to x plus the other one. I've got two fractions, I want to add them together, I need a common denominator. Thankfully I have a common denominator. And what am I left with? 2y squared minus 2x squared plus 2x squared minus 2y squared. And something nice happens. 2x squared minus 2x squared is 0. 2y squared minus 2y squared is 0. 0 divided by anything is 0. That is a solution. Hopefully that went well for you. Any questions at any time, you can obviously pause me, but also email me questions.